Hi, this is lesson 5 in JASP, and today we're looking at the within subjects t-test or within groups t-test. We're going to use the same data set that I've been using and continue on that to see how much we can learn from just that one data set. So go to Open and go to Data Library and to Descriptives. Open Data Library Descriptives and get the sleep data. And once again, as a reminder of what's being done with this data, we have participants who slept on one night. We got how much time they slept. Then we gave them one type of drug, and we saw that they slept some extra time. Specifically, they slept about an average of 0.75 hours, which would be about 45 minutes longer. And then we gave them on another night a second type of drug, and they slept 2.3 hours, which would be about 2 hours and 21 minutes. Go to previous videos for more on that. I'm going to erase all that. I'm going to look at the data. And the data that we've been looking at last time in lesson 4, we did an independent groups t-test because this data is structured in such a way that we have group 1 and then group 2, as though they could be independent groups. But they're not independent. We have subject number 1. They took the first type of drug and slept an extra 0.7 hours. And then person number 1 took the second type of drug and slept 1.9 hours. I have the same 10 people doing drug 1 and then doing drug 2, same 10 people. Now this data is organized in what's called long form. Long form refers to the idea that any repeated measurements are done on different lines of data. And we're going to turn that into what's called wide form data. Now, wide form data is how the data from most programs, like if you were to collect this data using SurveyMonkey or Qualtrics, most likely it would come out, unless you did something a little bit fancy or weird, most likely the data would come out in wide form. In order to change this into wide form, we're going to learn a new skill. We're going to go ahead and we're going to export this data. I'm going to export it to my computer, and I'm just going to stick it on my desktop. And I'm going to call the data how it is called already, which is sleep, and it wants to export it out as a CSV file, so that's what I'm going to do. I'm going to let it export the data. Okay. And now I'm going to go and pick up that data set as a CBS data set. I'm going to open it up and I'm going to manipulate it. And so what I'm going to do here is show you just an easy manipulation without really programming it. I'm just going to copy and paste. What I'm going to do is I'm going to go ahead and insert an extra column. And for the first column, I'm going to say this is extra for drug number 1, referring to how many extra hours they slept when they were taking drug number 1, which is exactly what's represented here. But I'm going to do that all with my column name, right? Instead of having column C here, which is now for group, tell me that it's drug number 1 or drug number 2. I'm going to indicate that in the name. And then I'm going to do another one called extra drug number 2. And my persons are located in the same order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can easily just go ahead and pick this up and go copy and take these people over here. And now I can see that without having to look at this information over here, I can see person number 1 got 0.7 hours extra sleep with drug number 1. They got 1.9 with drug number 2. Person number 2 slept less with drug number 1, got 0.8 more with drug number 2. So all the information over here is now over here. And now I can just get rid of all of that information. And the group information I no longer need, so I can delete that. I now have all of the same information. It might take you some time to think this through, and you might have to pause and kind of go back and forth. It might take you some time to think it through, but I have all the same information. I have that person numbers. There were 10 people. They were numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They used drug number 1, and then they used drug number 2. But now, having this data in long form, I now have the data in wide form. That is, each row tells me all the information that I need to know about person number 1, as opposed to having to look, oh, here's a little bit of information about person number 1 up here, and now go down over here and say, here's more information about person number 1. All of the information about each person is located on the rows, and that is wide form. And you'll notice that it's now a shorter data set. So long form is longer than data in wide form. Wide form data is wider than data in long form. Okay, so now I'm going to go ahead and save that. I'm going to save as my sleep data and just replace that as a CVS, get rid of that. I'm going to go back to JASP. And let me just get rid of JASP as it stands, open up JASP new. And now I'm going to go and open it from my computer. And I'm going to open it from the desktop. And I look down here and I see where I've saved sleep. And there it gives me a preview of the data in wide form. And I'm going to open that up. Okay, so there's my data in wide form. And now I'm going to do a paired samples t-test. I open that up and I take how many extra hours of sleep they did with drug number 1, put it in here, and now it's ready for a pair. It wants a pair. So it wants to see what I'm going to compare the extra hours of sleep from the drug number 1 with another variable, and now it's extra with drug number 2. And now it gives me my t-value, which with the probability value, a probability of a type 1 error being less than 0.05. Substantially less, you could say. Let's go ahead and look at the location parameter and the confidence interval. So it's saying that the mean difference between my groups is 1.580. That's exactly what I had when I did the independent groups version of this. It's saying that my Cohen's d, my effect size, is pretty large, a minus 1.285. Before it was a minus 0.8 in that range. We're going to look at the descriptive statistics. It gives us exactly the same descriptive statistics as we had before. We see exactly the same mean for how much they slept with drug number 1, exactly the same amount of extra sleep they got for drug number 2. And the difference between these means is exactly the same thing. If you take minus 0.75, minus 2.33, if you're confused, refer back to my video number 4, where I did this another way, treating these as independent groups, but now we see it treated as as a matched pairs, or what's called also called a related samples t-test. We're still seeing the same difference, but we see that the amount of error in that difference is substantially less than what we had. You can see that in the graphs here, because these graphs, the error bars are not overlapping in terms of the distributions like they were in the graph that we saw with lesson number 4, treating them as independent groups. If I go ahead and do rain cloud plots, I basically see now the lines are connected. I'm still seeing the same box plots that I saw before in lesson number 4. I'm still seeing the same density plots that I saw in lesson number 4, and the data points are still shown to be the same. But the difference is that now I see the connections between the data points. There's a line connected for every person. And I basically see that almost every person is responding the same way. Almost every person is sleeping more with drug number 2 as with drug number 1. So let me tell you what was happening for what the difference is. When we looked at this as an independent groups t-test, this error was about twice as much, because the error referred to the differences between each person that you would normally see, plus the differences in how they respond. When you do a within subjects t-test or a paired samples t-test, or we call it a repeated measures t-test, or we call it a related samples t-test, all essentially, for the most part, the same thing. When you do this version of the t-test, it's no longer paying attention to the errors between the error that's caused looking at differences between people. It's only looking at the error in terms of how they respond. And there's not that much error. I only see one line that's going down for one person. It looks to me like only one person is responding with less sleep. Almost everyone else is responding with more sleep. And so that's giving you much more power and showing you that when you take this mean difference and divide by this reduced error, you get this larger t-value of minus 4.62. It's almost twice as much as if when you did the independent groups t-test, and is now statistically significant. That's the related samples t-test, or what they call here the paired samples t-test. And again, I'll be back with more in future videos.